nice. December 2019, there were 2 examinations. One is for all over India and another is for Assam only. So in this lecture, we will be discussing the problems on the all over India question paper, and in the next video, we will discuss exclusively for Assam paper. So in this paper, totally 3 questions were asked from integral equations, 1 question from part B and 2 questions from part C. The first question is, let phi be the solution of the integral equation, then phi of 1 is equal to. Phi of x is equal to, so I'm going to take the differentiation of this one using Leibnitz rule. Phi dash of x is equal to minus 2 minus 8x plus integral 0 to x. Differentiation of this part is 6 times minus 4 2s are 8 into x minus t into phi of t dt, and applying the upper limit part, plus 3 plus 6 into x minus 4 into x minus x the whole square, the whole thing into phi of x, minus lower limit part is 0. So this is equal to, that is phi dash of x is equal to minus 2 minus 8x plus integral 0 to x, 6 minus 8 times of x minus t into phi of t dt. These two gets cancelled. X minus x is 0, x minus x is 0, so only 3 will be left, 3 into phi of x. Right. So again, taking Leibniz rule, phi double dash of x is equal to a minus 8 plus integral 0 to x. Differentiation of this part is minus 8 phi of t dt, and the upper limit part is plus 6 minus 8 times of x minus x into phi of t, phi of x, plus 3 times of phi dash of x, because lower limit part will become 0. Okay, by using Leibniz rule. By using a Leibniz rule, I have taken the differentiation. Now, phi double dash of x is equal to minus 8 plus integral 0 to x minus 8 into phi of t dt. This one vanishes, so only plus 6 into phi of x plus 3 into phi dash of x. Now, again, taking differentiation using Leibniz rule, phi triple dash of x is equal to, this one becomes 0 and integral becomes 0, only the upper limit part, which is minus 8 times of phi of x, and then plus 6 times of phi dash of x plus 3 times of phi double dash of x. Now this is an ordinary differential equation. So phi triple dash of x minus 3 times of phi double dash of x minus 6 times of phi dash of x plus 8 is equal, 8 into phi of x is equal to 0. The auxiliary equation will be m cube minus 3m square minus 6m plus 8 is equal to 0. So when we solve, it is 1 minus 3 minus 6 and 8. 0 1. If I substitute minus 2 here, minus 1 into minus 2 is minus 2, so I'll have minus 5. Phi 2 is 10, so I'll have plus 4. 4 into minus 2 is minus 8, 0 here. So we get one root is 1, m is equal to minus 2 is the solution, and others are m squared minus 5m plus 4 is equal to 0. Find the roots of this one, multiply should give 4, and when added should give 5. So 4 and 1, minus 4 and minus 1. So we will have m is equal to 1, m is equal to 4, and m is equal to minus 2. So the solution is phi of x is equal to a e to the power x plus b e to the power 4x plus c e to the power minus 2x, right? So from the question and from the derivatives, we need to get the conditions so that we can find a, b, c. Phi of 0, if I substitute phi of 0, what happens here? This integral part vanishes. This one goes 0. This one goes 0. So phi of 0 is equal to 1. And then for phi dash of 0, phi dash of 0, it will be equal to, here, I'm finding it here. Phi dash of 0 is equal to, this part becomes 0. This integral part becomes 0 minus 2 plus 3 times of phi of 0. Phi of 0 is 1, right? So minus 2 plus phi of 0. Phi of 0 is 1. So I'll have it as minus 2. This for 3 times of phi of 0, minus 2 plus 3, so I'll have it as 1. Phi dash of 0 is also 1. Next, phi double dash of x. So phi double dash of 0 is equal to, this integral part 0, and minus 8 will be there, and this part here, phi of 0 is 1, and then phi dash of 0 is 1. 6 plus 3 is 9, 9 minus 8 is 1. So phi dash of 0 is also 1. So I'll use all these conditions to evaluate the value of a, b, and c. Phi of 0 is equal to 0, phi dash of 0 is equal, phi of 0 is equal to 1, phi dash of 0 is equal to 1, and then phi double dash of 0 is also equal to 1. So how do we solve this problem? A e to the power x, and then I need phi dash of x, which is equal to a e to the power x plus 4b e to the power 4x minus 2c e to the power 2x minus 2x. Phi double dash of x is equal to a e to the power x plus 16b e to the power 4x minus 2 into minus 2 plus 4c e to the power minus 2x. So when I substitute these conditions, I will have 1 is equal to a plus b plus c, because I've substituted here in phi of x 0, e power 0 is 1. So I'll have a plus b plus c is equal to 1. This is my first equation, and 1 is equal to a plus 4b minus 2c, and 1 is equal to a plus 16b plus 4c. Now I am going to put all of these in matrix form. This is 1 1 1 a b c, and then here right hand side is 1 1 1, all three 1, and this coefficient of a is 1, coefficient of b is 1, coefficient of c is 1, and then here solving the system of a linear equation 1 4 minus 2 1 16, and then 4 here. So only considering A matrix 1 1 1 1 4 minus 2 1 16 4. So let me take this matrix to be M, because already we have used the denotation A, capital A. So let me take this matrix M. This is M matrix, this is X matrix, and this is B matrix. This is B matrix, right? So I have taken this M matrix exclusively. So this is similar to, I'm going to do row 2 implies row 2 minus row 1, and then row 3 implies row 3 minus row 1. So this is 1 1 1 0 0 here. 4 minus 3 is 4 minus 1 is 3, minus 2 minus 1 is minus 3, 16 minus 1 is 15, 4 minus 1 is 3. Now I need to solve again. So this will be R3 implies R3 minus 5 times of R2, 1 1 1 0, or else I can directly substitute ABC. Let me substitute ABC directly, or else you can make this term also 0 and then substitute the value. I'll go directly. So if I go directly, I'll have a plus b plus c is equal to, in the right hand side I'm having 1, because this is equal to 1 1 1, right? So I'll have a plus b plus c is equal to 1, and for the second row operation I'll have it as 3b minus 3c is equal to 0. That implies b is equal to c. And from the last row I'll have it as 15b minus 3c is equal to 0. Since b is equal to c, I'll have this to be b, right? So 15b minus 3b is equal to 0. So I'll have 12b is equal to 0. Then b is equal to 0. So that implies c is also equal to 0. c 0, b 0 means a is equal to 1. So the solution is y of x is equal to a e to the power x, right? So a e to the power x. So I'll have a to be 1. So e to the power x is the final solution. Now what is the question? Y of x. Now phi of x. The question is in phi. So phi of x is equal to e to the power x. They have asked phi of 1. So phi of 1 will be equal to e. Phi of 1 will be equal to e. So e. Third option is the correct answer. Moving to the next question, assume that h1, h2, g1 and g2 belongs to the continuous function on the closed interval a comma b, and phi of x of the Fredholm integral equation is given. Now statement 1 states that if the given integral equation has the solution of for some f, then this condition should valid. And for S2, if the given integral equation has a unique solution, then lambda is not, okay, if lambda is not a characteristic number of the corresponding homogeneous equation, then this should have a unique solution. So we need to find each statement by statement. First, for the first statement, I'm going to find by taking an example which satisfies the given conditions, and I will just verify whether this condition, this part is getting verified or not. For that, I'm going to consider the example phi of x is equal to, let me take f of x is 1, lambda is equal to 1, and integral 0 to pi cos of x minus t into phi of t dt. So here it is equal to 1 plus integral 0 to pi cos x cos t plus sin x sin t into phi of t dt. So this is equal to 1 plus integral 0 to pi cos t cos x plus sin t sin x into phi of x into phi of t dt. Now look here, h1 of t, g1 of x. So this will be h1, this will be g1, this is h2, and this is g2, right? So I must arrive at integral 0 to pi f of t, I've taken it as 1. G1 is cos x, so I'll have cos t into dt, which is equal to 0. I must arrive at this one, and this is 0 to pi sin t into dt is equal to 0, and both are equal. This is what I have to arrive at, then condition. Now if condition is they have a solution. Now this is a past year question also, so this has a solution for sure. Let us prove that this has a solution. Now phi of x is equal to 1 plus cos x can be taken outside, integral 0 to pi cos t into phi of t dt, plus sin x can be taken outside, integral 0 to pi sin t into phi of t dt, and phi of x is equal to 1 plus cos x c1, and then plus sin x c2. So c1 is equal to integral 0 to pi cos C1 is equal to integral 0 to pi cos t into phi of t dt. When I apply phi of t here, this is 1 plus cos t C1 plus sin t C2 into dt. So this is equal to integral 0 to pi cos t into dt, plus C1 can be taken outside. Cos square t will come. Cos square t is 1 plus cos 2t by 2 into dt. And this way here C2 can be taken outside. Sin t into cos t is sin 2t by 2. So this is integral 0 to pi sin 2t sin 2t by 2 into dt. So this is equal to integral 0 to pi cos t is equal to sin t 0 to pi, and this is going to be 0 plus c1 by 2, and integrating it we'll have t plus sin 2t by 2, and applying the limit here. When you apply 0, everything vanishes. When you apply pi, sin vanishes, only this part will be left over. So c1 pi by 2, and this is c2 by 2. When you take the integration here, it will be minus cos 2t divided by 2. So here cos 2 pi will be 1, and cos 0 is 1. So 1 minus 1 0. So this one is also 0 plus 0. Here C1. So C1 minus C1 pi by 2 is equal to 0. So that implies C1 outside 1 minus pi by 2 is equal to 0. I'll have C1 is equal to 0 because 1 minus pi by 2 is not equal to 0. C1 is equal to 0. Next for C2, which is equal to integral 0 to pi. What is C2 here? C2 is equal to sin t into phi of t dt. So sin t into phi of t is cos t plus C1 cos t plus C2 sin t into dt. So this is equal to integral 0 to pi sin t, wait, 1 plus C1 cos t C2 sin t. So this is 1 plus C1 cos t 1 plus C1 cos t plus C2 sin t. So sin t into dt plus C1 outside, integral 0 to pi sin t into cos t is sin 2t by 2 into dt, plus C2 outside, integral 0 to pi sin square t is 1 minus cos 2t divided by 2 into dt. Just now we saw that sin 2t by 2, it is going to vanish, and this part is going to be 0 here. And then plus this integration of sin t is minus cos t, so cos t 0 to pi, and this one here plus c2 by 2, integration of this part is t minus sin 2t by 2 0 to pi, and in the left hand side we have c2. C2 is equal to minus of cos pi minus cos 0. Cos pi is minus 1, cos 0 is 1, so it is equal to plus 2 here and plus 0, and then here it is when you apply pi here, pi will come, and when you apply 0, everything will become 0. So it is plus c2 by 2 into pi. So I'm going to bring this C2 pi by 2 this side. So C2 minus C2 pi by 2 is equal to 2. That implies C2 1 minus pi by 2 is equal to 2. That implies C2 is equal to 2 divided by 1 minus pi by 2. So I'll have class C2 is equal to 4 divided by 2 minus pi. And the denominator is never 0 because 2 minus pi is a number. It is not equal to 0. So C2 we got it as 4 divided by 2 minus pi. Now I'm going to substitute it in phi of x. So I'll have phi of x is equal to 1 plus cos x into C1, I got it as 0, plus sin x into C2, I got it as 4 divided by 2 minus pi. This is my solution. Phi of x is equal to 1 plus 4 by phi of x is equal to 1 plus 4 by 2 minus pi into sin x is my solution. So I am getting a solution for the given integral equation. Okay, now let us verify this condition is getting verified or not. Integral 0 to pi f of t into g1 of t dt, which is equal to sin t, integration will give you sin t, and 0 to pi it is 0, yes. And here this way minus cos t here 0 to pi, which is equal to minus of minus 1 minus 1, which is equal to 2. 0 is not equal to 2, and here they have given both are equal to 0. So the statement 1 is false. Statement 1 false means this option is false and this option is also false. For the second statement, the given integral equation has a unique solution for every f if lambda is not a characteristic number of the corresponding homogeneous equation. Okay, this is a theorem. I'll give you the theorem. And also we can prove in the other way. So the theorem states that if I take a homogeneous non-homogeneous Fredholm integral equation, let me take the non-homogeneous Fredholm integral equation. Phi of x is equal to f of x plus lambda times of integral a to b k of x comma t, into phi of t dt. And this k of x comma t should be of this type. K of x comma t is equal to alpha 1 of x into beta 1 of t plus alpha 2 of x into beta 2 of t. If this is of this type, then we have for the homogeneous type, f phi of x is equal to lambda times of integral a to b k of x comma t into phi of t dt. Of this type, we will have, if lambda 1 is not equal to lambda and lambda 2 is not equal to lambda, then that implies phi of x has a unique solution. So we consider a non-homogeneous system. We take the homogeneous part. If the lambda 1 is not equal to lambda and lambda 2 is not equal to lambda, then phi of x has a unique solution. Right. And the second is when lambda 1 is equal to lambda 2 is equal to lambda, then this is a corresponding function. So the corresponding eigenfunction is phi of x. Okay. So phi of x, the corresponding eigenfunction to lambda. In this case, if integral a to b psi of x into f of x. So this homogeneous is only for the unique case. Okay, and for this case we take the f of x. If f of x into psi of x, if it into dx, which is equal to 0, then we get that implies phi of x has infinitely many solution. If in the other case, if integral a to b psi of x into f of x into dx is not equal to 0, that implies psi of x has no solution. This is a theorem, right? So apart from the theorem, let us solve from the given condition. Now from the given condition, phi of x is equal to f of x plus lambda times of integral a to b h1 g1 plus h2 g2 into phi of t dt. So now they have given as to consider for the homogeneous condition. So f of x will vanish. Only phi of x will be there. Phi of x is equal to lambda times of integral a to b h1 of t into g1 of x plus h2 of t into g2 of t into phi of t dt will be there. Now, if lambda 1 is not equal to lambda 2 and if lambda 1 is not equal to lambda and lambda 2 is not equal to lambda, then in that case what happens? We'll discuss here. Now, phi of x is given to be f of x is 0. So, we should consider only the homogeneous part, which is h1 of t into g1 of x into phi of t dt and plus lambda times of integral a to b h2 of t into g2 of x into phi of t dt. This is what given, right? So then this is phi of x is equal to lambda times of g1 of x can be taken outside a to b into h1 of t into phi of t dt and then plus lambda g2 of x into integral a to b h2 of t into phi of t dt. Now I will consider this as C1 and this as C2. Now if I consider so for this condition C1, if lambda 1 is not equal to lambda and lambda 2 is not equal to lambda, in this case I'll have C1 is equal to C2 is equal to 0. Okay, if this is so, then I'll have phi of x is equal to 0. Right. So for the non-homogeneous condition, what happens here? The homogeneous condition, I'm getting phi of x is equal to 0. So for when I consider this f of x, I'll have this phi of x is equal to f of x. So this implies an unique solution. Right. So this implies an unique solution. Or else, if you're not understanding this properly, then let me take a particular example. Phi of x is equal to, let me take lambda is equal to 1. Okay. Integral a to b, that is integral 0 to 1. X plus t into phi of t dt. Now I have this h1 to be 1, g1 to be x. This is x plus t. G1 to be x. And then I have h2 is equal to t and then g2 is equal to 1. This is what I'm having here. And while solving the problem, what will I do? Phi of x, I have taken lambda is also equal to 1. Lambda is equal to 1. Okay. Now phi of x is equal to integral, I can take out x, integral 0 to 1 phi of t dt plus integral 0 to 1 t into phi of t dt. So I'll take this part to be C1 and this part to be C2. So C1 is equal to integral 0 to 1 phi of t dt and then C2 is equal to integral 0 to 1 t into phi of t dt. And after this, I'll have this phi of x to be x C1 plus C2. Right. So when I substitute, phi of t will be equal to C1t plus C2. Right. So this will be C1 is equal to integral 0 to 1. Phi of t is C1t plus C2 into dt. So C1 is equal to this way here. C1 outside integral 0 to 1 t into dt plus C2 integral 0 to 1 dt. So C1 is equal to C1 t squared by 2 0 to 1 plus C2 is 0, like it is T 0 to 1. So C1 is equal to C1 by 2 when I apply the limits, and this is C2. So I'll have C1 minus C1 by 2 is C1 by 2. 1 minus half is half, which is equal to C2. So I have C1 is equal to 2C2. I got this way here. Okay, and I should find for C2. C2 is given to be integral 0 to 1 t into phi of t dt. C2 is equal to integral 0 to 1 t into phi of t dt, which is equal to integral 0 to 1 t into what is our phi of t? Phi of t is C1t plus C2, right? So this is C1t plus C2 into dt, which is equal to integral 0 to 1 C1 t squared into dt plus I have C2t. C2 integral 0 to 1 t into dt, which is equal to C1 can be taken outside, t cube by 3, 0 to 1, C1 into t cube by 3, 0 to 1, plus C2 into t squared by 2 into 0 to 1. So I have in the left hand side I have C2, right? So C2 is equal to C1 into 1 by 3 plus C2 into 1 by 2. So I'll just bring this half C2 there. So this implies C2 by 2, which is equal to C1 by 3. So I have, which is equal to 3C2 is equal to 2C1. So from these two equations, C1 is equal to 2C2. So instead of this C1, I'm going to substitute 2C2. So I'll have this as 3, I'll have 3C2 is equal to this 2 times of C2. So instead of this one, wait, C1 is equal to 2C2. So instead of this C1, I'm going to substitute 2C2. So 3C2 is equal to 2 times of C1 is 2C2. So 2C2. So I'll have 3C2 is equal to 4C2. So I'll have C2 is equal to 0. If C2 is equal to 0, C1 is equal to 0, eventually 0. So you can just remember this as a condition when it is of homogeneous type and Fredholm integral equation is given. When lambda 1 is not equal to lambda and lambda 2 is not equal to lambda, we get C1 is equal to C2 is equal to 0. Okay. Yes. So from this condition, we get phi of x is equal to 0, and then we will have a phi of x is equal to f of x, therefore unique solution. So unique solution S3, this part, S2 is true, this is true. So S1 is false, S2 is true. So option 3 is true and option 4 is false. Moving on to the next question, phi of x is equal to 1 plus 2 by pi integral 0 to pi cos squared x into phi of t dt. We need to find the nature of the solution, right? So here I'm going to solve the problem by the matrix method. Phi of x is equal to 1 plus 2 by pi into integral 0 to pi cos squared x into phi of t dt is given. Now this is your kernel. Alpha 1 is equal, this is your alpha 1, beta 1 is 1. Okay. So from this matrix method, Ax is equal to B. So I'll have A is equal to 1 minus lambda A11, which is equal to 1 minus what is our lambda 2 by pi into A11. We need to find A11, and then matrix X is equal to C1, and then we have this B matrix is equal to V1. So A11 is equal to integral 0 to pi alpha 1 into beta 1, that is cos squared x into dx is equal to 1 plus cos 2x divided by 2, which is equal to 0 to pi integral dx. So I'll have 1 by 2 outside. When I integrate x plus sine 2x divided by 2, 0 to pi. When I apply the limits, I'll have it as pi by 2. So this is equal to pi by 2 for A11. And then we need to find this V1 matrix, right? So V1 is equal to integral 0 to pi f of x into beta 1. So f of x is 1 here, and then beta 1 is also 1 here into dx, which is equal to x 0 to pi. So it will be pi minus 0, simply pi. This is our V1. So I'm having the A matrix, the 1 by 1 matrix. So this will be 1 minus lambda A11, 1 minus 2 by pi into A11. A11 is pi by 2. So 1 minus 2 by pi, A matrix is equal to 1 minus 2 by pi into pi by 2. Pi cancels, 2 cancels, 1 minus 1, which is equal to 0. So I get a 0 matrix. Rank of A is equal to 0. So I will just find for rank of A by B, the augmented matrix. What is A by B? Rank of A by B, that is equal to, we need to find what is our A by B matrix. A matrix is 0, by B is pi. B matrix will be pi, right? So this is simply pi. This is equal to pi here. Rank of A by B is equal to 1 here. Rank of A is not equal to rank of A by B, so no solution is the correct answer. Thank you.